Hi guys, welcome back to the vlogs.
Okay, 9.5 is trapezoids and kites. Okay, once again, we're just going to get rules about trapezoids and kites, and it's going to be lots of formulas you have to have memorized to solve these things. Okay, so trapezoids and kites. A trapezoid, okay, is a quadrilateral with just one pair of parallel sides. So in this case, this side and this side are parallel. Okay, so it has one pair of parallel sides. We've talked about that at the introductory of this chapter, yes? Okay, the trapezoid has one pair of parallel sides. Here's a bunch of things that trapezoids have or don't have, okay? Definition is that it's a quadrilateral with just one pair of parallel sides. The bases, okay, the parallel sides, okay, are considered your bases. So this is a base, this is a base. Okay, so your base is here. You have two bases, one base here and one base here. Okay, the bases are the parallel sides. Angles that share a base are called base angles. Here's a base angle, these are a set of base angles, okay? And then these up here are a set of base angles. So you have two sets of base angles, and you have two bases, okay? Remember on an isosceles triangle, how if these are congruent, what does it mean about these right here? About this angle and this angle? They're congruent. It's called base angles theorem. Bases, the base angles are what then? Congruent, okay? So trapezoids have two pairs of base angles shown with, I just drew over them. It says black and green, but. So if you have two sets of bases, their base angles are congruent. We're going to learn about that in a minute too, anyhow. Okay, so isosceles trapezoid theorem. If the quadrilateral is an isosceles trapezoid, just like an isosceles triangle has congruent base angles, an isosceles trapezoid has congruent base angles. Only if it's an isosceles trapezoid. Do you understand what I'm saying? Okay. So, if it is an isosceles trapezoid, each pair of base angles is congruent. So if this side and this side are congruent, that means angle A and B are congruent, and it means angle D and angle C are congruent. Okay, both sets of base angles become congruent when it is an isosceles trapezoid. Not just any trapezoid, an isosceles trapezoid. Okay? Okay, so let's say that on this trapezoid PQSR, that PR and QS are congruent. What are the other three angles? No. What is angle Q? Let's start there. What? 102. How can I figure out what R and S are? Do you think they equal 180? We can try and see. First of all, how much does that interior, okay, yes, they do what? 360, because I have four sides. 4 minus 2 is 2, right? 2 times 180 means that this trapezoid interior angle is equal to 360. Okay, so if you know that both of these are 102, what am I going to do with that information?
Add them together and subtract it from 360.
Good, so 360 minus 204, right? So you get, what, 6, 5, 156. Now what do I do with that? And what happens when you divide 156 by 2? You get 78.
Yeah.
Is that correct? So angle R and angle S are 78. Good job, Faith. Way to know that it's 360.
Thank you.
Okay. Do we understand how I got that? If it's an isosceles one, I can solve for that, okay? If it's not an isosceles one, they have to give me 3 of those 4 angles. You get what I'm saying? to figure out what the fourth one is, because I know the inside equals 360. Or they have to give me like this one, and then I can draw triangles and bisect it, right? And the triangle would equal 180, and if this was like 102, that means it would be 51, right? And if this is 78, then it would be what, 39, and I would do 39 plus 51 and get what the third angle is. Does that make sense? Subtract it from 180. So you can solve these. Okay, another rule about isosceles trapezoids is the isosceles trapezoid diagonal theorem. If a quadrilateral is an isosceles trapezoid, notice how all these rules only deal with isosceles trapezoids. And I don't think I can stress that enough. Then its diagonals are congruent. So AC right here becomes congruent with BD, which means I've now broken things up into triangles and I can start to prove things. You will have proofs, is what I'm saying. Okay, because I have a triangle here, right? And I have a triangle here. And I've got stuff, this and this are congruent, this overlaps, this and this are congruent, side, side, side.
Pardon.
Fun stuff like that, yes? Okay? So you can start to prove things with these. And remember, this is only if it's an isosceles trapezoid. Good, Kayla? Yeah, okay. Okay, so then we get things called mid-segments and trapezoids. Trapezoid mid-segment theorems, okay, plural. A trapezoid's mid-segment is parallel to each base. What do we know about lines that are parallel? What can I start to do if I have something that cuts through them? What happens? Yeah, so if I have a transversal that goes through parallel lines, I create interior and exterior angles that are congruent. I create vertical angles that are congruent, okay? So I can do a lot of things through this. Because remember, I have diagonals that cut through here. Yes? Okay. So I can start to prove things again. So mid-segment theorem tells me if ABCD is a trapezoid and EF is the mid-segment. Mid-segment means that it's cutting AD and it's cutting BC in half, yes? Okay, the 2 points, which means what formula do you think I have to figure out or use to find mid-segments? How can I find the middle of this line? What formula? Yeah, midpoint formula. So if I ask you to create a mid-segment, you would have to find the midpoint of this line and the midpoint of this line and then connect the dots. Okay, does that make sense? Because they're going to ask you to do stuff like that. Okay, so if ABCD is a trapezoid and EF is a midsegment, then EF is parallel to AB and EF is parallel to DC. Midsegment length, okay, there's another rule for midsegment theorems. Midsegment length is 1/2 of the sum of the base lengths. So I add DC, I add AB, I multiply it by 1/2, and you get how long EF is.
So you add DC and AB
And then times by 1/2. So you might have to work that backwards. They might tell you this is 30, okay? This is 27, or this is 30, this is 35, what's DC? So you might have to work it backwards, like 30 equals 1/2 of 35 plus X and work it backwards. Does that make sense? Okay, you're gonna have to work it both ways. So then we get to, look, this one's worked both ways. Okay, so in this trapezoid above, AB is half of CD. What is EF?
So is this the 4 equals 1/2?
Yeah, 4 equals 1/2. Now, what is AB?
2.
2. So equals 1/2 of 2 plus, I'm just going to say X. Okay? How do I solve from there?
Distribute.
I wouldn't distribute. Why make it harder on yourself? How do you get rid of 1/2?
Divide by.
Or multiply by 2. So that cancels out. Flip and multiply. Just make it easier. So 8 equals 2 plus x, yes?
Yeah.
Subtract 2, yeah? So 6 equals x. Okay, does it make sense that this is larger than those two numbers?
Yes.
Yes. Now look at this. 6, 4, 2. What do you notice about that? It's what? Okay, it's even, but think more specifically about those numbers. How does 6 and 4 compare? 2 over 3. How do 4 and 2 compare? It's half, right? Okay, so I have a pattern going because it's 6, 4, 2. I've got something going on there. It's like decreasing as we go by the same proportion, okay? So that's how I'm going to solve that. Now, kites. Notice how kites break up into lots of triangles. Okay, kites. Okay. Kites. Its diagonals are perpendicular. So this is a diagonal of a kite, and this is a diagonal of a kite, and they create 90-degree angles. Okay? Which is good because now I have 4 90-degree triangles. And I can solve things. Okay? So, on a kite, the diagonals, and A to D is a diagonal, okay? And B to C is a diagonal. They create 90-degree angles, perpendicular angles, okay? Only angles formed by the unequal sides are congruent, okay? So what that means is this side CD is congruent to BD. The side AC is congruent to the side AB.
Oh.
Okay? So on a kite, I have 2 sets of congruent sides. The short sides are congruent to each other, the long sides are congruent to each other. And I know that their diagonals create perpendicular bisectors. Okay? Now look, this triangle using well, if I can prove it, because I'll bisect those angles or whatever, I can use side, angle, side to prove that this triangle is congruent to this one. Same thing up here. I got lots of stuff going on that I can start to prove. Okay? Now, this is just showing you again. Its diagonals are perpendicular. Only angles formed by the unequal sides are congruent. So here's another part to this aspect. Only angles formed by the unequal sides are congruent. Meaning this angle is congruent to this angle, okay? Only angles formed.
What does it mean by unequal sides?
Yeah.
Okay, like this side and this side are unequal. Those two come together to form this angle
Oh, so
that
is
is
that
congruent to that angle.
So is that what BA and CA wouldn't be considered unequal because they're at the same side?
Correct. Because BA and CA are the same length, they're not unequal sides. Okay, so only the angles formed by the unequal sides are congruent. Okay, which means that angle A and angle D aren't necessarily congruent. They're not formed by unequal sides. This side here and this side here are the same length. Okay, the only set of angles that are congruent is angle C and angle B. Does that make sense? Because back here, remember, we said that these sides are all congruent, right? These two are congruent, these two are congruent. We said these perpendiculars, so these are all 90 degrees. But what we're saying is when this happens, this unequal side and this unequal side meets to create 2 congruent angles. Okay? So don't get confused on which angles are congruent. Okay? It's where the large and small side meet opposite of each other. With that being said, I can start to solve things. Okay? It says, what's the measure of angle CBA? So they want to know what this angle is here, CBA. How can I figure that out?
47 plus 90, and then subtract that by 360.
Okay, why do you say that?
Because 360 is what all the angles equal, and we already know that the A is 90, and they're all equal 90.
Okay, so what's 180 minus 137.
180 minus.
Yeah, because reducing the triangle.
Oh, you're fine. Oh, I knew that.
You can do it your way, it would just take one.
3.
8 is
43.
7, 9, 10,
That's
3,
3.
yep, 4,
4.
43 degrees.
Yeah.
Now, I have a question. If this angle is 43 degrees right here, right? Okay? What is this whole angle down here?
The whole angle
Mm-hmm.
plus 43 plus 8.
Can you figure that out? Do you have enough information? to figure
Wouldn't
it out?
we? Because they're congruent angles.
Well, this whole angle is congruent to this whole angle, yes?
Yeah.
Do you know what this portion is here?
No.
Do we know if it bisects it or not? I don't know.
Let's assume.
Let's play around with something and see something, okay? Think with me for a second, let's play something. Let's say that these do bisect, okay? Then this whole angle becomes, instead of 47, what's that whole angle become?
47
Mm-hmm. 7 times 14, 94. Okay? This becomes 94. This would be 43 and 43, which would be 86, yes? And this would be 86, yes?
Yeah.
Okay.
So don't we find what we were looking for?
Well, time out. We're thinking. Okay? This has 1, 2, 3, 4 sides, right? So the whole inside has to add to be what?
360.
360. What's 86 plus 86 plus 94?
Someone would calculate that.
266.
266. And what's 360? 360 minus 266.
Wait, I have a
That's
question.
What?
94. Why are,
Don't mean nothing.
how do you know the two, 43 and then the other?
We don't yet. We're playing around with something.
This is
So, Priya, you would say that then this has to be 94, right? Do we know that this angle and this angle are congruent?
No.
No, so we don't know that that's right. So we can't just assume that this is congruent, okay? I was just proving to you that it might not work, so don't assume stuff, right? Even though we tried to prove it, but we really can't. We can only prove that that's 43 degrees, okay? So that's where we're gonna go from here. That's the end of this,
One person.
okay?
One person. Come on. Like, subscribe, comment, tweet me at David Dilberg. Anything else to add, Bryson?
It's game day, you know what I'm saying?